clicked it.
Okay. Hello, everyone. We'll be starting our presentation in about 3 or 4 minutes. Hi, Thomas, are you ready?
Yes, sorry about that.
Oh, no problem. Well, thank you, everyone. Sorry for the delay. I just want to say good afternoon and welcome to the University of San Francisco's MSDS seminar series in data science. My name is Sean Butcher, and I'm the Partnership Director for the Data Institute. This seminar is brought to you by the University of San Francisco's Masters in Data Science program and sponsored by USF's Data Institute. Each year, we partner with companies and organizations around the San Francisco Bay Area and beyond to provide 9-month internships for our students. During their degree, our master's students spend 15 hours a week working with a company to tackle their data science and analytics problems. We're beginning to plan our internships for this fall. So if you or your organization is interested in supporting the Data Institute or working with our students, please contact us by email at datainstitute@usfca.edu. Alternatively, you can visit us on the web at www.usfca.edu/data-institute. Today, I'm pleased to welcome Dr. Tomasz Palczewski. Tomasz is a staff software engineer at Samsung Research America and an ex-researcher at the University of California, Berkeley. Today, he will be talking about his personal journey from academia to business through data-driven projects. We'll leave some time at the end of the talk for questions. If you have questions, please enter them in the Q&A button at the bottom of the screen. Don't use the chat area. We won't answer questions in the chat area, so please use the Q&A button. Welcome, Tomasz.
Thank you so much. So let me share my screen. Okay. Can you see my screen right now?
Yes.
Yes, I can.
Okay, thank you so much. So first of all, thank you for this opportunity to talk here today. So my name is Tomasz Palczewski, and in this presentation, I will try to show you two projects, one that had like roots in academia, and the second one slightly from a different perspective, mainly from the business side. And I will try to showcase a few differences between the work that we do in basic research in academia and the work that is done in the business settings. So just a formal statement at the beginning before I start. So here I will just talk about my personal opinions. I will also share some kind of work that was done at the University of California, Berkeley, and at the Inside AI program. I'm not longer affiliated with those institutions. So in terms of things that I will present for the Samsung Research America, these are only publicly available information. So I will not really talk about any projects that we do at SRA. So I hope you understand this and you won't ask any tough questions that could lead to hard answers for me, because I don't want to break any NDAs. So having this done, I will start with this slide. So I was thinking about how exactly, present. At the beginning, I thought, okay, maybe I should just, take like one or two papers that I co-authored and like, show this in a typical, way as we do in scientific environments. But then I realized, okay, maybe, it won't be really so much, interest in that, keeping in mind that this, meetup should be tailored to, young data science enthusiasts. So I decided to do this in a slightly different way. I will try to, show like a big picture. I will not go into many details here in this presentation. I don't really have time to spend much time on models here. So I will just, try to show different things, and I hope from the side that might be interesting for people who are like finishing their PhD studies, maybe a postdocs who want to transfer from academia to business. So please keep this in mind. Okay, let me go. So I will start this presentation with a few words about me, and it might be funny, but I believe that, if you have opportunity, you should try to sell yourself. You never know what kind of new exciting opportunities are behind the corner. So that's first advice that I'm trying to give, young people who are thinking about, how to get at their first jobs. Then I will say a few words about graph neural networks for signal classification in IceCube. That's the work that we finished with a paper accepted at ICMLA, and this paper got the best paper award. The work was cross collaboration with Michael Bronstein and Jean Bruna. Then I will try to say a few words about systematic errors, and mainly, from the perspective of how can we interpret our models, how can we understand them better, and I will try to, answer, maybe not really answer, but give you some insights on these questions. Do we really need, the systematic errors? Do we really need interpretation in business? And then I will present a very, I would say, basic project that I did that is based on the face detection. And for that, I will focus mainly on the business side of things. So through the presentation, I will try to, address different things, mainly differences between academia and jobs in Silicon Valley. At the end, I will just present like 3 or 4 slides about Samsung Research America. As I said, this will be like publicly available information. And maybe it's worth just to, wait till the end of this presentation for some people, if they feel like bored in the middle, maybe just try to wait, because at the end I will also say a few words about the internships and, the positions that we are trying to fill. So yes, let's move on. So I have a PhD in elementary particle physics. I also was exposed to economics through my studies of management science. Currently, I'm an executive MBA candidate at Quantic. I have around 5 years of postdoctoral experience at the University of Alabama and the University of California, Berkeley. So right now I'm, as it was already mentioned, I work as a staff software engineer at Samsung Research America, but I'm also a principal research scientist at a startup called Micronet AI. In general, when I was making this transition from academia to business, my work was mainly divided into 3 different areas. So I was performing statistical analysis in basic research. I was doing some kind of machine learning and deep learning. I would like to say that recently this chart changed a lot. So I would say that this slice connected with deep learning is much larger right now, and I see that for young data scientists, people who want to make the transition and so on, deep learning is getting a lot of attention, and we should really spend a lot of time trying to understand different models. So not only, I see that in data science positions right now, it's not only, classic machine learning, but there's a lot of projects that are done using deep learning models. So just last slide about me, and I'm showing this, not just to, show you that I was in a few different places and I work, in Asia, in Europe and US. I'm showing this just to, try to tell you that right now we are living in the world that you can really have a collaboration in the, around the world. So you can really work with people in different institutions, in different countries. And I see that, people from US, from good universities like University of San Francisco are really, trying to get internships in Silicon Valley, and they are really thinking only about like FANG. I would say that in current situation, you have so many possibilities. You can try to work, in some kind of close collaboration with, even switching your vertical, not only focusing on data science, but maybe, trying to do something in basic research, in physics, in math, in biology, but using your existing skills that you are building in your during your degree. So I would say that, there are extremely cool opportunities out there. Maybe even you can, find some kind of a cool project in the IceCube experiment, and one day maybe you'll have a nice picture of yourself at the geographic South Pole. So please keep this in mind. So this slide just, try to summarize this part. So I think that, people recently are focused on internships in like FANG, but there are a lot of opportunities. Here is just one example. because some people think that, to work with big data, to work with, to gain experience in processing large data sets, to try to get insights from those data sets, you can only do this in Facebook, Google, and so on. And this is not really true. Here is an example. You can see that for LHC experiments at CERN, this is like the largest European laboratory in Switzerland, we have almost exactly the same scale of data process. And, I think that this type of cross collaboration is extremely useful and gives you some additional edge, because you are also, exposed to different perspectives. So people, from math background, from physics background, have a slightly different ideas, and they try to solve problems in slightly different ways than people from computer science or data science. So as a young data scientist, I think you should really try different verticals, try different projects, and I hope that when you open your mind on all these possibilities that you have right now across the globe, you will have excellent environment to learn different techniques and increase your understanding in data science problems. So right now, I will move on to the signal classification in IceCube. So, you might think, okay, this is like some kind of high energy physics, elementary particle physics. This is outside of my comfort zone. This is not really related to data science. And I will try to show you that this is not really true. So let's set the scene. At the left side, you can see an IceCube detector. That's just a huge set of strings. On those strings, we have those funny egg-like detectors, and we collect some information, light, that we then translate into the information about particles. So it sounds like, okay, this is physics, this is hard, but if we, frame this problem into a slightly different way. So what if I tell you that, based on the picture on the right side, where you can see Monte Carlo simulations, these are simulations that take our current knowledge and experimental results, and using them, we can generate different examples. So using those Monte Carlo simulations, we can, get some kind of a picture about how should, neutrino, our signal example, look, and how our background looks. So, looking at this right now, I hope you start to see that this is, a classification problem. And, you can try to frame this as a typical pattern classification problem. So do we have labeled data sets? Yes, we have. I showed you on the right side that we can use Monte Carlo simulation to generate our labels and our sets. So I think right now it starts to sound a little bit better. And, keeping this in mind, I think it opens a lot of possibilities for young data scientists to look at different fields, different verticals. So I don't really want to go into much details. I'll just show you some basic information about this work. So why is it hard? First of all, we have extremely sparse signal per example. So sometimes you have those very nice examples as shown here. There is a lot of information, but sometimes if the neutrino has a lower energy, we have just a few points here and there, and that's it. So the total number of these detectors is huge. It's like almost 5,000 detectors. So you can imagine that for some examples, you will have like an array of 10 or maybe 20 numbers out of 5,000 values. So this is sparse, extremely sparse. So so this is extremely sparse. We have extremely large asymmetry between positive and negative examples. And as I showed you, our detector is not really simple. So if you look at the top of the top view, you will see that this is hexagonal grid, and the distance between those DOMs is not constant. So in some places we have a shorter distance, in some places longer, and so on. So right now, let's try to solve this problem. So I would like you to, ask yourself, how would you solve this problem right now? And maybe if you have like some good ideas, maybe, write this in chat or, write this down. So we have, let's say, our detector. So this is like this box here on the left side is a representation of our detector. And we have some kind of a signal. So some kind of, red stars here in this picture at the left side. So how exactly we can think about this? So we can think about this as similar to image. So we have X, X, Y, and Z. We have some kind of a pattern we can think about. Maybe we can frame this as an image classification problem, binary, because we want to, our model to tell us, yes, this is a signal, or no, that's a background. Or maybe we can frame this in a slightly different way when we start to think about those detectors as nodes in a graph. Then we can try to, say that, this looks really like a graph. We have nodes. Each node we can, assign a specific feature connected with the physics variables, and then the distance between the detectors can be an edge in between two nodes. So yes, so that's what we thought, and that's what we tried. So right now I will try to convince you that this is a good approach. So I will show you some kind of results connected with convolutional neural networks and graph neural networks. But let's think which one should we use. Okay, so first of all, in general, you want to have some kind of a baseline result. So in both academia and in business, we try to use a baseline that is like a common approach, that is simple, that you can we can implement in a fast way, and maybe you won't get the best results, but at least you will have some kind of understanding. I would like to also mention here that data preparation is crucial, and unfortunately I don't have really time to talk about this, but right now I see that there is a transition, between thinking about deep learning models and some kind of new exciting machine learning approaches, and we are moving into at least in business, we are moving more towards better understanding of our data and how well we can perform ETL, how well we can version our data, how well we can store data sets, and how well we can then use them for machine learning on deep learning. And I think when you will make this transition from university to to your first job, you might end up in a startup like environment, and then you will really need to understand that data is crucial, and for a young data scientists, you might find yourself working on data almost all the time while making a very simple machine learning models just to give you some kind of results afterwards. So in general, I would say that models that you can explain are extremely important in basic research in academia, but in the business environment, it strongly depends on the requirements that you have. And I will not talk about evaluation metrics in this presentation, but it's also an important point that you need to consider making this type of projects. So in our approach, we tried CNN and graph neural network for this problem, as CNNs in typical settings, perform convolutions on orthogonal coordinate systems. So we needed to transform this, strange hexagonal shape into a grid. So we did this. We simply map those 86 strings onto a 10 times 20 grid, and then we added information about our detectors. So the final array shape is 10, 20, 60, and that was fit into a 3D CNN with 18 layers. Again, I don't really want to talk about model details here, but I think it's for me, it's more important that you understand that we took a physics problem, rephrased this into some kind of a data science problem, and then applied the existing methods that you can easily implement. CNN, that type of CNN can be easily implemented in TensorFlow with Keras within one day. So for GNN, why exactly we use GNNs, I try to tell you that we can think about those small detectors as about graph nodes, and the distance can be represented with graph edges. So the final architecture is just a set of T-graph convolution layers pooling, and then at the end we have sigmoid to get true or false information. If you are interested about details, please see our paper. Here is the link to the paper. I wanted to show this. Unfortunately, I had to move my presentation, and now it's in PDF, so I cannot really discuss how the CNN works. But again, I think it's not really as exciting how you apply those kernels and what exactly it means to get feature representation, dense feature representation. I think you can simply go to any introduction about CNN like models and learn something about that. What I would like to say is, if you are working with different projects, you will be exposed to different deep learning methods, to different machine learning methods, and it's good to understand how exactly those models work. But in business environments, you might be, in the situation where you want to, showcase your knowledge and present those models in detail. But in many cases, if you are talking with managers, with project managers, with TPMs, with even with data engineers, they might not have the same understanding as you. So I think the good advice is try to tailor your descriptions to the crowd that you are talking with. So here I just want to show you results we can see on the right side of this slide here is a true positive rate versus false positive rate. And we can see that GNN has the best result out of all of these methods. You know, somebody would get extremely excited about this and say, okay, so now we should only use GNNs in this vertical, and you know, that's the future. But I would like to really, you know, point out this sentence here that we put in our paper that you can read here on the left side. So, you know, this study shows the possibility of improvement. And you might think, why are you claiming only a possibility when you are seeing, you know, such a good result? And this is strongly connected with the fact that in academia, in basic research, we value interpretation, and we do value how exactly you can estimate systematic errors connected with your approach. So this part, I would say, is really missing in business. Yes, sometimes you need to explain deep learning models, but I would say this is really, you know, using like Shapley values. That's like a standard right now, and you don't really go beyond that. In academia and basic research, as you are really focused on one thing and you work in the specialized area, you tend to spend a lot of time on systematic error studies. Just to give you some kind of idea, I think I have here, you know, one link to a paper about statistical analysis of neutrino oscillations. And you can find in this paper that the authors tried 155 different systematic error sources. So you can imagine how much time was spent on the evaluation and on the interpretation of their approach, and comparing to, you know, simple training and delivering some kind of a product. So in business, we tend to work on the projects that have a very short time scale, from like a few weeks to a few months at best. So, you know, this is completely different environment and completely different approach to problem solving. So as I said, in business, I would say that people tend to use recently for deep learning Shapley values, sometimes maybe Lime, and sometimes permutation importance. But you can imagine that if you build like some kind of a custom model, then, you know, the existing libraries cannot really give you any insights about, you know, about what really is happening inside of this model. Therefore, in business, we really tend to, you know, make some kind of a statements about interpretation only about like a basic models. So I would say that XAI is a huge field right now, and if you are at the University of San Francisco, you are in good hands, and I hope that you will learn a lot about you know, how to interpret machine learning and deep learning models. Okay, so now I would like to switch gears and move to my insight project. So first of all, some kind of details what exactly was done there. So I was working on the object detection algorithm, face detection, and then I was applying a specific set of blurring to hide faces in still pictures or in videos. As I said at the beginning of this presentation, I don't really want to go into details about the models, but some basic information here is listed. So I tested as my MVP Haar cascade classifier. So this is like a classic machine learning approach for object detection. And for my second iteration, I used as back then state-of-the-art deep learning algorithm called YOLO. You only looked once. So this was a deep learning approach. So if you want to look at the code was done a few years ago, but sure, please feel free to check it out on my GitHub page. So that's the idea of the project. You have a picture. You don't really want to show your face, or you don't want to show faces of other people. You simply upload this picture to the web application, and you are getting back, sanitized, anonymized picture back. Just some background on the Haar cascade classifier. I showed you a few slides back how CNN works. We had those kernels, we just applied them. And, based on that, we get some kind of dense representation. Then we could use dense layers to make the classification. In the machine learning, we are doing this in fairly similar way. So you have a set of filters. This time, those filters are, hand-picked, hand-constructed. These are not learned kernels, and you just apply those to the pictures. And you train your model. You simply set the weights for those kernels, and you can see, for example, on the first picture on the left side, you have this kernel that can find like horizontal edges and so on. So that's the basic idea. So we know now about the models and what I'm trying to do. And now I will try to, look at this project more from the business perspective. So you don't really care about those models. So you wouldn't really discuss those models unless you would be asked to discuss those models. So, it's more about setting a right set of business requirements. So when the project starts, you would, work with the TPM, work with other PMs to really set your requirements. And based on those requirements, you'll start thinking about building some kind of application service, whatever you try to deliver. Again, please keep in mind when you are, making those transitions and you are starting to work in those in new environments, in your first job in business, not every person is a technical person. So not everyone will be exciting about models, will be exciting about, how you did your work. The excitement comes from results, from insights that you can deliver. So here is how I would, try to present this type of a project if I would have like 5-6 minutes, maybe 10 minutes. So let's look. Okay, so first of all, you need to make some kind of introduction, why exactly you are tackling this problem. This is like a first stage when you are discussing, okay, with project managers, how exactly you want to, solve this problem and why is it important. If everyone agrees that this problem is important, in this case, we are talking about face anonymization, and it's extremely important right now because, privacy is a huge topic, and we know that even if we deliver this product, we can use it also in different applications. So that's also an additional plus. So it can be used in access control, surveillance, in security, and so on and so on. So the main idea here is a pipeline. As you can see, we have some kind of input. You can present this based on some kind of example. Here you can say, for example, let's look at Google Maps, those cars that are driving around. In some states, when you are at your private property, no one can really take your picture and make it public. So that's a huge problem in those states for those type of cars to collect data. So we are saying we can solve this problem easily, even have this, face anonymization inside of this beautiful car and do this on device. We just need object detection and simple model to make blurring to hide faces. You can also pitch this in a different way. Say you can do this for faces. You can do this for different things like, for example, license plates, or maybe some kind of different objects. So who can use this? In general, I would say that, if you just create a very simple front app, everyone can use it. You can, open this app, and that can be used for private users, small and medium enterprises, and large companies. So as you can see in the slide, I haven't really talked anything about models. And in general, if I would pitch this type of a project, I wouldn't really say anything about models. If you really want, you can introduce something like that and, say, okay, so inside of this hide faces AI project, we have some kind of models. We can use pre-trained already models, or we can train those models using a data set. If we need to have a specific data set, you need to say how exactly you can collect your sample, and maybe you need the data augmentation, maybe you need different things to make this work. So this is how you can extend the picture from the previous slide, and maybe mention what kind of efficiency metrics you will use to evaluate your models. But again, from the business perspective, you are not really looking at the metrics connected with the model efficiency. You are looking at completely different evaluation metrics. You are looking at the metrics connected with the business that you are trying to perform. So in this case, it might be like, increase of revenue, decrease of, legal cases connected with the fact that you are showing pictures that are not correctly blurred, and so on. If you want, you can, for example, show a picture and say, okay, we tested a few different methods to, sanitize, to anonymize this picture. And we found that, like a combination of those methods give us the best result. And again, you are showcasing this to, to say that aesthetic of the picture is nice, that you don't really can tell who that person is in this picture, and so on. But you don't really, go into details of different techniques, and you don't really spend much time on, trying to say what's the difference between Gaussian blur and, for example, bilateral filter. In general, in the projects, you need to have some kind of output, and it strongly depends on your project. Sometimes it might be a simple, web app. Sometimes your input is consumed by other projects. So you need to be aware that you need to have all the requirements in hand before you start working. You don't want to have a situation where you deliver some kind of outputs, and other teams or other people cannot really use them, as they thought that you will deliver something completely different. So this is extremely important in business, that we work toward a specific goal, and everyone needs to sign out. All the stakeholders need to sign this before the project really starts. Here, because this is like a data science meetup, so I just like to show you some kind of challenges connected with the face detection. So as you can see here, for the hard cascade classifier, it was trained mainly on frontal face pictures, and you can see if we have a huge pose variation, so then HAR starts to have problems with those faces. And here is a very simple comparison that in the business setting you would like to show. As you can see, we are not showing anything about accuracy, and we are not showing anything about true positive, false positive rates, and so on. We are just showing this in a way where you can just look at this, and without really understanding of evaluation of data science projects, make some kind of judgment. And you can see from this slide that, okay, in this case, YOLO is much better. As you can see, if we have a lot of faces, it nicely finds all of them, and so on. Unfortunately, in our environment, in our setting that this project was set, YOLO prediction time was 3 times longer than for hard cascade classifying. And I wanted to show this because in some cases you might have a better model, but in terms of accuracy, but in terms of, for example, speed, or in terms of the interpretation that you can get from this model, it's much harder than the simple model that slightly underperforms, and still you will go with this slightly worse model, as you can gain more insight, assuming that you are above your required threshold. So I hope you guys guessed who was on the picture, and I think this summarized this part. So I tried to really show you that in Silicon Valley, we work a lot on different projects. We don't really are so specialized as in academia. And you need to keep in mind that some data scientist positions will be more focused on research. Some will be extremely applied, just to take whatever existing model there is, take the library, pre-process correctly data and apply this. So you can think about this. It strongly depends on you what exactly you want to do and how you want to move through your career. But it's important to not only focus on one single topic, I would say, these days. However, I noticed that deep learning, we see a huge movement, and recently I would say a lot of projects that I work on are mainly using deep learning applications. So I'm slowly moving to the end of my presentation. I wasn't really aware how much time should I talk, so hopefully it's not too long, it's not too short. So right now I just want to say a few words about Samsung. This is a very nice slide showing you, the revenue. It's huge, and they also invest a lot in R&D. We have excellence centers, research centers across the globe. The number of centers is somewhere here, I think 35 R&D centers. We are the first patent holder in the United States. So a lot of different things are happening in Samsung Electronics, but I will talk mainly about Samsung Research America. So what exactly we are doing there? This is a very basic picture. We are involved in a lot of AI, meaning deep learning projects. We do a lot of data intelligence. We work closely with excellent data engineers. We are trying to get as much insight from data as we can, and then move those insights into some kind of solutions, services, or products. Right now, there is a huge part of SRA that works on, on-device AI, on robots. Also, on there is a part where we are trying to do something in life care and new experiences, security, next generation communications. But I am from the visual display intelligence lab, so I'm more towards advances in deep learning and machine learning, and what exactly we can, how we can use those models to get more insights about users from how they consume content on Samsung connected TVs. So what exactly we do? As I said, I cannot really talk about details, but I can say that we do a lot of user behavior modeling. We do a lot of some kind of recommendation engines. We do content knowledge graph approaches. We don't only work on information collected from TVs, but also information connected from other devices, from mobile phones and from other devices like DVDs, PlayStations, and all that stuff connected to TVs. There is a huge work connected with the multimodal approaches in Samsung and also AI experience. So this is the last slide that I wanted to show about Samsung Research America, to give you some kind of idea how we can deliver different things, how we can construct services and products. So as you can see, we work, as I said, with our first party data. So mainly logs, mainly information about viewership, KPIs and stuff like that. You can see mobile information there, IoT as well, connected devices. But we also have a lot of third-party data about ads, networking, about demographics. So understanding of data preprocessing of ETL, how to move from raw data to something that you can use and build a product is extremely important. Here is some kind of a list of problems that we are solving and that we solved already, without going into specific details of what exactly we are doing, as this is yeah. So I think that work at Samsung Research America is extremely exciting. As you can see in VDIL, we have a lot of data. We do quite a lot of different projects, so you can, be involved in recommendation one day, and then maybe you'll just build demographic classification model. At some point, you might working on some work connected to ads, maybe something connected to marketing. So there is, a lot of open, exciting projects, and we need people to work on those. So we are hiring so you can find open positions here on this in this web page. And we also, at this moment, even in VDIL, we are looking for summer interns So hopefully some of you from University of San Francisco might consider applying for some intern positions at Samsung Research America. And that concludes my presentation. I hope it wasn't, too shallow, but I tried to, tailor this to, to the level of young, data science enthusiasts. Thank you.
Thank you, Tomasz. We're now going to spend a few minutes addressing some of your questions. If you have questions, please enter them in using the Q&A box button at the bottom of the screen. I did have a few questions from your talk while we're waiting for people to ask their questions. You mentioned quite a lot about dealing with non-technical people and having to persuade them of the benefits of a project. Do you find a challenge with non-technical personnel's opinions of what the technology can do and can't do? There's often a lot of hype around what AI is capable of and a lack of understanding of what it actually can do. How do you address that without going into too much technical details?
Yeah, that's excellent question. So, that was the hardest part to me, to be honest, because I spent like 5 years as a postdoc. And, I was used to the technical jargon and talking about, different things connected with deep learning. And when I switched, I realized that, showing, for example, F1 score to a project manager might be not the best idea.
Mm-hmm.
And that was quite shocking because, if you think about like basic, evaluation metrics, you think naively that everyone knows them. And this is like a basic information that people who work in AI should, have. Mm-hmm. Unfortunately, this is not really the case. And, you need to think, also try to, change your perspective and think about how can you, present your work in some kind of metrics that are connected with business. Mm-hmm. And that's a huge value. If you can, show that, okay, we have this specific model, it's quite complicated, but using this model, we can gain, revenue, something. That's the way to go. And I had a hard time, making this transition when I started to work in business.
We have a question from Terence. He asks, physics seems to be a good background for machine learning AI. Could you talk a bit about your background in physics and how it prepared you, and anything non-physics people can do to dig into that?
So yes, physics is excellent, at least high energy physics and elementary particle physics, because we did quite a lot of machine learning and deep learning, starting almost like 10-15 years back. So when I was doing my master's, even I was exposed to different machine learning models. Back then it was in C++, completely different environment, but still, you were able to get some kind of understanding of those models. And having this and having also a very specific knowledge about statistical approaches and be able to compare different methods gives you broader view. That's why I'm telling young people, try to find internships, not only in business. Try to go and ask maybe at some universities, change your vertical, go for physics, go for math, go for biology. You will be really surprised how people using those models, how people understand them. There are completely different perspectives sometimes on different problems.
We have another question. What advice do you have on leveraging past academic experience in the workplace aside from mathematical fluency? Having only a bachelor's in physics, I feel that I'm in an in-between of having a domain knowledge, but not necessarily the cutting edge subfields.
Yeah, this is one of the hardest part, because when you are making this transition, people in business like to see, okay, this guy, did this job for 5 years in a different company. So it means that he will be able to perform maybe on the same level, maybe on slightly better, maybe slightly worse. It's hard to, make this assumption about somebody who has only, theoretical knowledge. That's why I'm telling all the people who ask those type of questions, you should try to make some kind of projects. You should be able to showcase that, okay, I have technical knowledge, but also, look, I was able to implement a, very simple project, and not only focus then on, on the models, but focus on the big picture. So you can, show that, okay, I'm able not only to make those models, but I'm also able to make those models in my business setting, that I'm able to understand, that we are trying to deliver something, what we are trying to deliver, why we are doing this. These are the questions that sometimes people from academia don't really care about, because, when I was a postdoc at UC Berkeley and in physics, I was working in such a narrow field, high energy physics, neutrinos. So it was really hard to go beyond that.
Right.
And in business, you need to have this type of understanding.
We have another question. How do you deal with unrealistic expectations from non-technical persons at companies? For example, if they ask, why isn't your model 100% accurate?
Yeah, that's also a good question. So first of all, at the beginning of the project, always we have some kind of a meetings with all the stakeholders, and we are trying to set requirements. And this is extremely important, that you need to communicate, what is potentially possible and what's not. Right. So if somebody says, please deliver me a model that has 100% accuracy, you can, say, okay, that doesn't really make any sense. And, then you can, try to present why it doesn't make sense. You can, try to use your knowledge and your skills to, showcase that, okay, we can do something like that. We can, compare this with other, methods that were already implemented, and so on and so on. So setting requirements is crucial. Yes, we are working like an agile environment, and so on. Everyone thinks that, okay, this is like 2-week sprint. We are just, doing something that maybe will change, something different, but it's not true. At the beginning, if you don't have, precisely defined requirements, what's going to happen at the end of your project, you will fail. That's simple as that. So that's right. Crucial.
Surin asks, what are the traits that you're looking for in candidates applying for entry-level data science positions?
So yeah, I personally, like to see that the candidate is eager to work, is really, has some kind of projects, that showcase that, it's not just, that he took a book, spent 5 minutes, or like, find something, but he dig deeper into some kind of problems. But, in terms of like interns and, I think starting positions like junior data science positions, it's more about attitude. It's more about how you can showcase that you are a good fit, and not only focus on technical background.
Mm-hmm. I think we're just about out of time, but I did have one final question. From your perspective, having moved, worked in academia and moved to industry, what do you think would be more challenging about the other way, moving from industry to academia? Do you have any kind of perspective on what the different challenges would be there from your perspective of moving from academia to industry?
Yeah, that's a good question. So I think it would be maybe harder,
Yeah.
because when you are in your career and you are doing your master's, then your PhD, then you're a postdoc, you are getting more and more skills that are in a specific area.
Right.
And then, when you are in business, you are all over the place. You can do some kind of, classification project one day, then maybe you'll just do, some kind of recommendation system, maybe something else. So you are not really going into details as much. I'm not saying that's bad, but sometimes, understanding of those models in a deeper way could give you, additional edge, but sometimes it's not really so important as if you can deliver and this meets requirements, then you don't really need to understand all the details. I think that in academia, we spend a lot of time on projects. So it's not like in business, for example, I don't know, the recent project I did for Samsung was like, I don't know, 60 days or something like that. Mm-hmm. It's not really possible. So you need to have a different mindset in academia. Especially if you work in basic research and you want to study not only your get result, but also study systematic errors, understand the environment and everything, then it takes a lot of time. So different mindset.
Well, thank you so much, Tomasz, for spending time with us and giving us a perspective on your work. We really appreciate you being here. I think we're out of time right now, so I want to thank you and the audience for attending today, and I look forward to seeing some of you at our future seminars. Thank you so much.
Thank you so much. Bye-bye.